Hey everybody, this is Alex Merced from alexmercedcoder.com, and what I want to talk about today is just a lot of the basic foundational concepts in programming. The reason being is it's much easier to learn any programming language if you kind of understand what's kind of going on under the hood. So let's kind of have a chat about that just from a abstract basic level, and trust me, this will make learning programming and being a better programmer easier. Okay, so essentially what you're doing is the computer basically communicates through a bunch of zeros and ones. It's all what's called machine code. And what happens is that it takes a long time to program machine code to do anything, nowadays fancy. So over the years, what's happened is that different layers of languages have been built on top. So basically, to make machine code easier, there was assembly, which kind of abstracted from that a little bit, but it was still fairly complicated and fairly hard to read and not very human in a sense. Like, you're doing a thing, but you're not quite sure. It doesn't really say that it's doing the thing. And then, as you get closer to machine code, it's referred to as a lower level language. And the more that it gets abstracted, so the more you kind of take away all the little things going on under the hood, it's called a higher level language. So like JavaScript, Python, these are very high level languages where a lot of the things like managing memory and stuff like that just kind of gets abstracted away. So you don't have to necessarily really worry about that and just basically making instructions for your code to do what it needs to do. But at the end of the day, there is a finite amount of memory that your program has accessible to it. And that is always an issue, especially as the bigger your program gets, the more memory it uses and the more memory management becomes important. This is why when it comes to like 3D gaming and a lot more memory intensive type programs, you start using more lower level languages where you have much more capability of managing how your code manages memory. Cool. So that's sort of a thing. But every language has a certain ideas that you need to understand. There's data, there's certain information, and the information comes to different types, whether they're integers, which are just basically whole numbers, floats, and double, which generally is like a variable type thing. There is strings, which are basically lots of letters. There's a character, which is one letter. These are all types of data. And every language handles different types of data in their syntax differently, but you need to know there's different types of data, and a variable can only hold one type of data. It's holding either an integer, a float, a string, or a Boolean, true or false. So that's first things first. Then there are operators. Operators are the things that kind of instruct what to do with the data. So this is like addition, the plus sign for addition, the minus sign for subtraction. Those are math operators. Then there's Boolean operators. These are ones that try to evaluate whether something is true or false. So like an AND operator, an OR operator. So you're saying, if this and this are true, then true. If this or this is true, then true. These are called Boolean operations. So every language has generally the same Boolean and math operators, but occasionally you'll find some minor differences. But you need to know that, because I need to have data and I need to be able to evaluate whether that data meets certain conditions, because then I have control flow, which is if statements, which means, hey, if this is true, do this. If it's not true, do that. So that way your program actually branches instead of just doing a list of directions. But sometimes you want to repeat the same process more than once. So then you have loops, which allow you to repeat something over and over again until certain conditions are met. So those are sort of your underlying foundational concepts. And then you get to some sort of higher level concepts, which include functions. Functions are being able to encapsulate your code, like a bit of code that you probably want to use again. So maybe you're going to add two numbers a lot. So you may want to have a sum function that adds two numbers. But you don't have to type in, give me this plus this. You just want to have the code run. That's what a function does. It basically takes a list of instructions and assigns it to a variable name. Okay? So a lot of times they don't really, that level of it is abstracted, where it's really directions being assigned to a variable. In some languages, that distinction is a little bit clearer. But theoretically, there's two types of functions. There are impure functions. An impure function, you give it information, and it'll actually alter that. So if I gave it a list of numbers, and then it altered all those numbers, and then at the end, that list of numbers, the original list of numbers, doesn't exist anymore. All I have is the altered list. That's an impure function, because now the old data is gone. Then there's a pure function, which takes in data, maybe makes the same exact alterations, but instead of altering the original set of data, it just returns me a copy of the data with the alteration. So I still have the original set and the new set. So there's a school of thought called functional programming that basically believes that pretty much all functions should be pure. So basically, at the end of the day, you should always be returning a copy of the original data set with your alterations, not altering or mutating. So this is the whole word mutate versus immutability or immutable, meaning you can't change it. But either way, you can have functions that do both, and it's important to know when one function is pure versus impure, so that way you know how it's going to handle the data you put in. Makes it easier to kind of find your bugs later. But essentially, functions are, again, just lists of instructions that you pass information into, which is referred to as a parameter. It will do instructions, and at the end may return a value, give you something back. So you always kind of see this command that says return this, meaning, oh, I did my thing, I did your instructions, here's your thing back. Okay, and you can do something with it. So that's a function. But then there's a whole idea called object-oriented programming, where in object-oriented programming, you're trying to break down your problem into objects. Okay, so let's say you're creating a game where there's lots of different animals. Well, first we need to know what an animal is. So you might create what's called a class that defines what an animal is. And a class is a combination of variables, data, and functions, meaning things. So think of it as adjectives, things that describe it, the variables, and things that that object does, the verbs, and put together, it's the noun, the animal. So a class is what you're doing is you're taking a noun and describing the adjectives and verbs related to that noun. So you'll create this noun animal and say, okay, this animal has these different characteristics. It has fur, it has age, it has number of legs, number of teeth. You set up all these variables and you say, hey, this animal can make a sound, so that'd be a function saying, okay, anytime the animal makes a sound, this is what happens. Anytime they eat, this is what happens. Those are the verbs, the actions that the animal takes. And then you have this animal class. And anytime you need to make an animal, you can just create the new version of this class that has all this definition already built in. And even better, there's something called inheritance, okay? Where basically you can create a copy of an existing class. So you take that animal class and then instead of having to recreate all those details, since most of those details are gonna be the same for most animals, I'll inherit from it to make a dog class where I only have to change the parts that are unique to dog. Okay, so this is within the ideas of polymorphism and inheritance and whatnot. Okay, but every time I create so basically I have a class called animal, I inherit it and create a class named dog that has all the characteristics of animal plus more. And then I can instantiate a dog, which means I can actually create an individual dog named Sparky, okay, that has all the characteristics of dog defined in class. So I can create many dogs now. So that's kind of how class works. So the idea is you define your objects, so that way you can create as many objects as you need. Sometimes you don't need a whole bunch of objects. Okay, so I don't need to instantiate that class over and over and again. But I do need the class because it helps think through the logic of the program. It helps abstract things. So in that case, this is where you start getting into what's called a static class or static functions of a class, where basically instead of having to create a dog named Sparky that then barks, I might have a function that names all the count called dog count that's on the dog class that counts all the instances of dog. Okay, so I don't have to call Sparky doesn't call dog count, the class dog, that's static. So these are some of the basic ideas. And then there's, when I forgot to mention collection. So the idea is that you collect data into groups of information, and generally data collections where you put many variables in one thing come in two flavors. There's your standard array, which is basically a ordered set of data, generally always starting with the index 0. So the first item is 0, the second item is 1, second item is 2. And it could be any kind of data, string, numbers, whatever. And then there's key value pairs, where instead of saying, okay, this piece of data is in place 0 and place 1, every spot has a name and they're not in any particular order. So this could be a data set that's called Alex, me. And then the first variable is called name, or there is a variable called name that equals Alex. There's a variable called age that equals 34. These are key values. So key is name, value is Alex. And this data set has all these key value pairs. They have different names in different languages. So in Python, it's a dictionary. In JavaScript, it's an object. In Go, it's a map. It's the same thing. The idea is there's a key and there's a value. But this gets back to the whole memory management thing. When you create a data set, it's setting aside the memory for that variable when you declare it. You're saying, hey, I need a variable, and then the computer actually sets aside the memory for that variable. So when you create a data collection like an array, you need to tell it how many spots it has, so that way you can set aside that memory. Okay, so in lower level languages, you oftentimes have to say, okay, I want an array with 8 spots. But then what happens is that sometimes you need more space, and you don't know till you actually need it. So there's ways of dealing with that. So basically, in many higher level languages that abstract that problem away, really what they're doing is that instead of you creating an array, so when you create an array, let's say JavaScript, you're not creating an actual array. It sets aside a spot in memory, but really the actual array variable is really not the array itself, but a reference to the memory spots in the array. So in that case, as you add more information in the array, it's just adding more references. So this way, the array can be as big or small as you want. Go does this as well, in what's referred to as a slice. But the idea is that by working through its references, which in C++ would be known as a pointer, so the variable is not 1, but a address to in the memory where you can find 1. You can do some tricky things that give you a little bit more dynamic play, which requires you to kind of really play with all those pointers and addresses in like languages like C++, while languages like JavaScript, Python hide all of that. They kind of automated all of that, abstracted that for you, so you don't have to worry about it. But knowing that it does that helps you think through how your code is behaving as you learn the language. So this is just an introduction to many of these concepts. I recommend that you Google and read up more on these concepts, but this should definitely give you a solid start. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.